Hello everyone. So today I, Aditya and Vladimir are going to present you the paper An Image is Worth One Word. So we warmly welcome you to this session. Next slide, please. Yeah, so going over the intro. So the paper has introduced us with an analogy to basically understand what the paper is trying to achieve. So here we have a movie analogy. It is so in this movie, we are going to present uh, Uh, I'm sorry, I am getting some reverberation of the voice. If some if someone's mic is on, kindly turn it off.
Yep. So you need some help?
Yeah, so there was some voice reverberation. So maybe if the YouTube voice is on or something, I guess.
So okay, should I continue?
No, I will take care of that. Yeah, thanks. So in the analogy, the paper has introduced us with the movie analogy. Movie is called Titanic. So in one such scene, the character from the movie, that is Rose, asks Jax to draw one of his portraits. But she mentions that the background or the theme or style should be one of his previous work, which was French Girl. Also, she has introduced the final object or the main character as herself. So there were primarily two tasks in this part. First, the Jack should create a drawing, and in that drawing, the Jack should incorporate the style of one of his previous work, that is French Girls, and along with that, the main object or main character of the image should be Rose. So when Jack tried to combine these two things, it basically lands up with this portrait that I have shown at the rightmost top-down corner, bottommost corner. Next slide. So considering that analogy, why this paper and what is it is trying to achieve is we have already a lot of text-to-image models that are used to generate images based on the natural language description. However, there are certain issues when we try to use that model according to our case. So in such cases, one such issue is the lack of freedom. It is very critical and hard for us to basically ask the model to generate something according to what we need, according to our style. So this challenge is basically handled by this paper, and they have introduced us with a very simple approach. Next slide, please. So this is one such example that has been given in the paper. What they have done is they have a images batch, like 3 to 5 images, and from that images they basically extract one word that is called pseudo word. So when they extract the pseudo word, we will later explore how they do that. And when they extract the pseudo word, they basically add the pseudo word to another prompt. Let's say like we have this an oil of painting of S star. S star here basically denote the pseudo word that has been extracted using some techniques. So when we extract this text word, we can use this text word along with some technique to basically generate the images that is relevant to our style. Let's say whatever we need, we can pass the prompt and the pseudo word, and we can generate the images in the relevant style or need that are relevant to us. So how all these things work and what are pseudo case, how it is generated, I am passing over to Vladimir, and he will take care of this now. Thank you.
Okay, thank you, Aditya. So yes, we are now switching to methods of this article. And indeed, the main problem of these text-to-image generation models is that our language is not expressive enough. In this particular example of this statue, this figure, this green figure, it's very difficult to describe it with only one word. It's basically impossible. And even if you imagine a paragraph of text describing this particular statue, it doesn't guarantee that the text-to-image model will produce exactly this one. So we need a particular word for exactly this object. like one row word, like in the movie Titanic. We need rows in our model. In the case of avocado chair, everything is simple. We know how the chairs look like, how the avocados look like, so it's not difficult. But in this case, it is extremely difficult. And in order to understand how is it possible to create a special word, this pseudo-word for this object, we will make a step backwards to the latent diffusion models, which we exactly use in the article we are talking about now. So here is quite a complicated scheme, but let's try to go through it all together. So this is how the diffusion models work. We start from the image X and encode it into the latent space. In the latent space, it is very convenient to work because the dimensions are lower, so the computer resources are not so high. You can use less computer power for processing images, and then you can combine this latent representation of your image with some additional input, like from the text input. So basically, you've got a latent representation of your image, and then you've got a latent representation of your text, in our case. You can combine these two together, like here it is passed to our latent space in this place. And then you perform several times denosing procedure. So you move along the latent space with these transformers, like t times, and on output you've got a denoising, like denoising procedure, which will give you further your image backwards. Okay. So if it works like this, we have got this text input and we have got an image on output. We should try to find the solution here in this small block of text. And this is exactly done in the paper we are talking about. So we have got an input, like a photo of our special object, which is further processed, like tokenized, separated in words, and then connected with some dictionaries. But there is a very special word which should describe our object, this as with a star. And for this, you know the embedding vector. So you don't know, you want to construct it. You want to construct this embedding vector. For all other words, the embeddings are known. This is the only vector you need to construct. Okay, and then we can try to invert our problem of text-to-image generation as follows. So here are two equations. They look quite difficult, but let's look at them close, have a closer look on them. So this is the loss function for the latent diffusion models for the text-to-image generation. And in these models, you basically train these network. You've got this denoising procedure of the transformers, these theta parameters, and you have got text input over here, and you train both these parameters to perform a perfect image when giving on input some text. But in our case, when we already have an image and want to describe it with only one word, which can be further used to generate new images, we will not touch these parameters, these theta parameters. Instead, we will pass the images to it, to our model, and then we'll try to find such a vector in the latent space, which will minimize our loss function. So we keep these parameters fixed, and they are already pre-trained by somebody else on huge computers. And we are here with our small laptops. We'll try to find this latent vector, which will describe our object with only one word. So this is exactly our word, single word for our object. This is our rows. Okay, this is how it works. And let's have a look how it what are the results. So here is an example. Once we have a special word generated for an object, you can have all the benefits from the text-to-image generating models. Here in the example, we have got 3 images of this skull mug, which looks quite complicated. And if you try to describe it with several words, it will be almost impossible. And in approach of the work we are discussing, they managed to generate these new 3 photos of this mug, this skull mug, which looks pretty similar to ones which were given on input. For a comparison, the author presented the results from the famous Dahlia 2 model, which was also given the same images on input. Of course, they also presented the outputs of the same model and other models with the text input, where they try to describe such skull mark with the words. But definitely it didn't work. You can try by your own, but it's impossible to describe this mark in such a way to produce some similar images. Okay, once we know that our approach works, we can try other tasty features of text-to-image generation. As an example, we can create a special word for this unicorn and try to ask our text model to create this unicorn in the Minecraft style. So how does our unicorn will look like in the Minecraft? Or, for example, we can think about small teapot and what will happen if it will be in a huge Death Star from the Star Wars movie. And we can see that the results almost the ones we can expect what we would like to have when typing such a prompt. You can make a step further and, for example, download the images of your child to this model and see how your child will draw such famous pictures like a Scream from Edvard Munch or The Starry Night by Vincent van Gogh. And they will basically look like following, which is quite nice. So you can combine this, transfer this style from the input to some other text input. Yeah, okay. There is some other possibilities. For example, you can create these special words for a style, which is depicted here on the left, and the special another word for such a cat, and try to draw such a cat in a style depicted on the left, which will look like follows. So basically you have all the benefits of the text-to-image generation models, but now you can work with really complicated objects, which you basically usually can't describe with a single word or even with a paragraph of text. And this brings us to the summary. To conclude and to remind that in this article, actually the authors use the concept of the pseudo-word creation, like filling the gaps of our alphabet, of our vocabulary. And this approach was based on the latent diffusion model, which is open source. The similar approach can be used with any other models with only slight modifications. And of course, it is obvious that such a new method have various different practical applications. And the authors also suggest further fine-tuning of the model, such as, for example, conserving the shape of the object when trying to modifying it, or, for example, to speeding up the process itself. because for the moment they have used 2 GPUs, and to create a single image, not to create a single word, you need about 4 or 5 hours of operation time of 2 GPUs, which is still okay, but not accessible with a personal laptop. This brings us to the end of the talk. And if you have any questions, please feel free to ask them.
Yes, Sushma, to answer your question, the application of this paper is to find text or words to describe an image. Yeah, in the first part, it does that. And in the next part, it basically use that pseudo word in various of, I can say, use cases, as Vladimir mentioned in the slides. Regarding any good it can do for the society, so there are several use cases we have mentioned. So for each, like there are multiple practical scenarios in which we can use this paper for good scenarios. I'm not able to actually mention any one particular case, but yeah, like there are practical uses. Like we can have some images in our own style. Like if we want to have a particular mascot for our logo in our own style theme, so we can have that. So in similar sense, we can have multiple practical case, which can also serve as uh, good purpose for the society. Okay. Okay, I guess if there are no doubts, we can conclude this session. Thank you everyone for joining.